determination of crystal structure from systematic absence of certain planes, of certain crystal planes. Let me write simply planes, certain planes in X-ray diffraction pattern, in XRD, X-ray diffraction pattern, or XRD simply, right? Determination of crystal structure from the systematic absence of certain planes, right? Yes, what is meant by this? Listen, we know very well. uh, I'm going to focus mainly on cubic crystals. Okay, so our focus is mainly on cubic crystals. For cubic crystals, okay, right? Now we know very well, according to Bragg's equation. So we know very well Bragg's equation. What Bragg equation says is that n lambda equal to 2d sine theta. This we know. Okay. We are going to focus on first order reflection. So put n is equal to 1. We are going to focus only on first order reflection. So this n equal to 1. So you'll get lambda is equal to 2d sine theta. Okay. So this is the Bragg's equation for first order reflection. Now what I'm going to do, for cubic crystals, we know very well about the interplanar distance for cubic crystals. Okay, so let me take this as equation number 1, right? For cubic crystals, in general, whether it is simple cubic or body centered cubic or face centered cubic, okay, the interplanar distance, this is the formula we use. D is equal to A by, A is the edge length or lattice parameter, divided by square root of h square plus k square plus L square. So this is the interplanar distance for particular HKL planes. Okay, interplanar distance for some particular HKL planes. Okay, this formula is applicable only for cubic crystals. Note down. I am going to substitute this in equation 1 here. Okay, so if I substitute this in equation 1, what will happen? Let me write in the next page. Sir, come. Now let me substitute this interplanar distance d for cubic crystal in equation 1 here. So if I substitute, what will I get is lambda is equal to 2 into, in the place of d, I'll put this value a by square root of h square plus k square plus L square into sine theta. Okay. Now I'll keep this angle in one side and bring the remaining term to the left hand side. So what we get is lambda by 2a, I'll bring this 2a to the denominator this side, into square root of h square plus k square plus L square is equal to sine theta. Now we take square both sides. On squaring both sides, we can write this as sine square theta is equal to lambda square by 4a square into h square plus k square plus L square. Okay, take note. This is a very important relation. Listen, in powder XRD, specifically for powder XRD or Debye-Scherrer method, we fix the lambda. Okay, lambda is fixed, right? And what is A? A is called edge length of the unit cell. Okay, it is called crystal parameter. Edge length is a fixed value, right? For a given crystal, it is it is constant, right? A is fixed for a given crystal, for a given cubic crystal. If some cubic crystal is given, then edge length is a constant. So for a fixed wavelength, right, 4 is constant, A square is constant. So I'm going to replace this lambda square by 4A square. It is a constant. I'll take this constant as, say, for example, K. Okay, so instead of this, I'm going to write this simply as K. So sine square theta equal to K into H square plus K square plus L square. Okay, remember this expression. This is very important. From this, we can say that sine square theta is directly proportional to, because K is constant, I can write sine square theta is directly proportional to H square plus K square plus L square. Okay, take note. So what I'm going to do, I'm going to write set of or family of particular planes, and the corresponding H square plus K square plus L square value, how it is related to sine square theta. Then for simple cubic, BCC, FCC, what are the values? Okay, so first one I took 100 planes. Family means 100 plane, 010 plane. Let me write here 100, 010 plane, then 001 plane. All these planes, then 1 bar, 00, 01 bar 0, 001 bar. All these planes are called family of planes. Okay, all these planes will give rise to one signal. Okay, in XRD. I repeat, 100 plane, 010 plane, 001 plane, 1 bar 00, 01 bar 0, 001 bar. All these planes are called family of planes. One family. They belong to one family and they will give one signal. Okay. Now what is the corresponding H square plus K square plus L square value? H value is 1. K and other values are 0. So if I take square, 1 square is 1. So I'll get 1. Okay. Now H square plus K square plus L square equal to 1. You know very well what is sine square theta? In the last page I wrote. Sine square theta is equal to K into H square plus K square plus L square. Okay. Now we got the value of H square plus K square plus L square, which is equal to 1. Now what is the sine square theta? It is nothing but K into this. So I'll get K. Okay. Yes. Then next set of plane I'll take 100. The next one is 110. Let me take 110 plane. Okay, and we'll write all possible values here: 110, 110, 101, 011, 1 bar 1 bar 0, all the possible families, right? They are all come under one family, and for this family, H square plus K square plus L square is equal to 2. H value is 1, K value is 1, so 1 square plus 1 square plus 0 square, and if you sum up, you will get 2. 2 into K, you'll get 2K, right? That is a sine square. Next, sine square theta possible for this family. Similarly, we have different family of planes like 111 plane. Okay, then we have 200 plane, family of planes. 200 planes. Then we have 210 planes, 210, right? Etc. 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 Many planes are there. Observe carefully. In a similar manner, we can find H square plus K square equal to 3, 4, 5, 6. Okay. Then 7 is not possible. Observe carefully. 7 is not possible. Right? Listen. We get sine square theta at 3K equal to 3K, 4K, 5K, 6K, 7K is not possible, then 8K, okay, then 9K, 10K, 11K, like that it goes. Let me write that in the next page. I'll just show you the sine square theta alone. Sine square theta values, possible values. Okay, 1K, 2K, 3K, 4K, 5K, 6K, 7K is not possible, 7K is not possible, then 8K, 9K, 10K, 11K, 12, okay, 13, 13K, then we have 14K, okay, let me write here, 14K, then I don't have space there, I'll write 15K. Observe carefully, this is very, very important. This is very, very important. Listen, here 7K is not possible. Similarly, 15K also not possible. Okay, these informations we get from the possible planes, right? HKL values. Whatever HKL value you take, you can't get h square plus k square plus l square equal to 7. Similarly, whatever HKL values you take, you cannot get h square plus k square plus l square equal to 15. Okay, I'm going to do, listen, I'll write the rules, extinction rules for cubic crystals. What is the rule? Cubic crystals. Okay, for simple cubic crystal, suppose if you take simple cubic, for simple cubic, all these values are allowed. Okay, you will get peak at K, right? Then peak at 2K, peak at 3K, 4K, 5K, all values are allowed. 6K, 7 is not possible, 7 is not possible. Then 8K, 9K, 10K, 11K, 12K, okay, 13, 14K, all values are allowed. 15 is not possible. Then 16K, like that goes. Okay, for simple cubic crystal, right, according to extinction rule for cubic crystals, we got this information. Okay, try to remember, for simple cubic, all these planes will give lines or peaks in the X-ray diffraction pattern. Okay, next one for BCC, for body centered cubic crystals. Okay, which are all the planes are allowed, and what is the rule? Extinction rule. Extinction rule is very simple. Reason, for body centered cubic crystal, this H plus K plus L value should be an even number. Okay, H plus K plus L, if you add, okay, that sum should be an even number. If you get H plus K plus L equal to even, then those planes, those reflections will give a signal in the XRD. Right, those planes reflect the X-rays, and that reflected X-ray will give signal in the X-ray diffraction pattern. Okay, so this is very important. In the case of simple cubic, all HKL values are allowed. All HKL values are allowed. You can take, you need not worry about whether it is odd or even. Any number is allowed. For BCC, only those planes will reflect the X-rays. Only those planes will reflect the constructive interference, for which H plus K plus L should be even. Okay, so, and remember, 0 is even. Observe carefully, in crystallography we take 0 also as an even number. Therefore, if you take the first one is 100 plane, right? This K, first K corresponds to 100 family, right? H value is 1, K 0, L 0. If I sum up 1 plus 0 plus 0, what will I get? 1 plus 0 plus 0, what will I get?
1, sir.
1 is an odd number, right? 1 is an odd number. Therefore, reflection from this plane is destructive. Okay, it is destructive, so you will never get any signal in the XRD. So there is no signal for K. Okay, listen, next one I'll come to 2K. What is 2K? 110. Listen, for 2K, it should be 110. Okay, 110. If I add these 1 plus 1 plus 0, we get the answer as 2, correct? In the previous page, I wrote everything. Listen, I wrote here. First family of planes will get 1K. For second family of planes like 110 plane, we get 2K. So for 2K, the planes should be 110. If you add all these values, 1 plus 1 plus 0, I'll get 2, which is an even number. Therefore, 2K will appear, will give signal in the XRD. So for 2K, we'll get a signal. Then for 3K, we'll get a signal. I'm sorry, for 3K, sum is 0, odd. You will never get signal. For 4K, we'll get signal. So adjacent value, see, 2K. Then for 4K, we get 5K, no signal. Okay, 5K, no signal. 6K, we get a signal. 6K, we get a signal. Then 7K, no cubic crystal will give signal for 7K and 15K. Keep that in mind. Then for 8K, we'll get a signal. For 9K, no. For 10K, yes, we'll get a signal. 10K will give signal. 11K, no signal. Okay, 12K will get a signal, right? 13K, no signal. 13K, no signal. 14K will get signal. Like that, we get. Okay, take note. FCC crystals. Listen, for FCC unit cell number 3, for FCC, phase center cubic crystal. Okay, HKL values should be either all odd, all the values should be odd, or all the values should be even. Only those planes will give reflections of X-rays, and those X-rays are only those X-rays are 1 second. So for phase center cubic crystals, HKL values, all the values should be odd, all should be odd, or all the values should be even. Only those planes which will reflect X-rays, and those X-rays will undergo constructive interference and will give signal in the spectrum or in the XRD pattern, diffraction pattern. Okay. Now for FCC, okay, this is very important. For FCC, you won't get signal for 1K, you would get signal for 2K. The first signal will appear for 3K. Then no signal for for 4K will get a signal. 4K will get a signal, and no signal for 5K and 6K. No signal for 5K and 6K. Obviously, 7K, definitely cubic crystals won't give peak at 7K. Then we get signal at no signal for 8K, and we get a signal at 9K. 9K, no signal at 10, right? No signal at 11, like that it goes. No signals. Okay. Then we'll get a signal at a simple FCC 9, 10, no signal. 9, I'm sorry, 9, 8, 9, 10. For 8K, we get a signal. 8K, we get signal. 9K, no signal. 10K, no signal. 11K, we get a signal. 11K. In the next page, I'll write clearly so that you can easily understand this. Listen. Up to this, any doubt? Now I'm going to write these values in ratios. That is, I'm going to remove that K, which is somewhat confusing, right? So I'll remove the K and write the ratios of the peaks, okay? Right? What is meant by that? Listen. So I'm going to take ratios of the sine square theta, ratio of sine square theta. If I take ratio, what value will get? Listen. Number 1, for simple cubic, observe carefully. For simple cubic, we get a line at 1K. Just write 1. Then we get 2. Okay, 2K. Then we get 3K. Then we get 4K. We get 5. Right? These values corresponds to h square plus k square plus l square. H square plus k square plus l square, because we know very well sine square theta is proportional to h square plus k square plus l square. For simple cubic, all HKL values are allowed. So 1, 2, 3, H square plus k square by L square can be 1. H square plus k square plus L square can be 2, 3, 4, 5, 6, 7 not possible, I have told you. 7 not possible, then 8, 9, 10, 11, 12, 13, 14, right? 15 is not possible, then 16, like that it goes. This is for simple cubic. Okay, H square plus k square plus L square values can take these numbers. Okay, so these planes will give signal in the spectrum. Number 2, I'm just repeating whatever we discussed just before. I'm just repeating in without k, that's all. For BCC, what are the values allowed? Listen, uh, actually we get a peak at 2k, 2, then 4, then 6, all even, right? 2, 4, 6, 8, 10, 12, 4, 12, then 14, etc., etc. It goes. Listen, 2k, 4k, so for us, these numbers are very clear. But in the X-ray XRD, okay, we can see only the ratios. The ratios will appear like this: 1 is to 2 is to 3 is to 4 is to 5 is to 6 is to 7 is to 8 is to 9 is to 10, like that it goes. Okay, this is the ratios of the peaks, right? Anyway, try to remember all these things. Then for FCC, for phase center cubic crystals, we get signals at 3k, 4k, 8k, 11k, 12k, etc. Okay, remember no peak at 7k. Here also no peak at 7k, no peak at 7k, no peak at 7k, and no peak at 15k. Okay, these are all values for FCC. Then I'll give for diamond cubic also. For diamond cubic crystals, the allowed possible values are 3k, 8k, 11k, etc. Okay, take them. For FCC, I have told you for FCC, HKL value should be all odd. All the numbers should be odd, or all the numbers should be even. All even. These are allowed. Okay. So if you take all odd, means 1, 1, 1. All the numbers are odd numbers. Then 2, 0, 0. All the numbers are even. I told you 0 also even. Okay. Then 1, 3, 5. All the numbers are odd. Okay. Then 2, 2, 2. All the numbers even. Now listen. You take the sum of. You take square of these numbers and take the sum. 1 square plus 1 square plus 1 square. We get 3. Am I right? For this plane, 1, 1 plane, take the squares of these numbers, h square plus k square plus L square, then sum up. You'll get the answer as 3, correct?
Yes, sir.
So for BCC, we will get a peak at 3k. Then take this one, take the squares of these number and add 2 square plus 0 square plus 0 square. What we get?
4.
4. 4. You won't get signal at 7 for cubic crystals, so leave it. Then what about 8? See this one? See, I have another plane. See, 2 to 0. What is 2 to 0? All the numbers are even, right? 2 to 0. All the numbers are even, right?
Yes, sir.
If all the numbers are even, all odd means it should be FCC. Now, take the squares of these numbers and add them. 2 square plus 2 square plus 0 square. What we get?
8.
What is the sum? What is sum? Sum is equal to 8, right? So we'll get signal at 8. We'll get signal at 8. Okay. Right? What about this 113? 113. All the numbers are?
Odd, sir.
All the numbers are odd. So this plane will give signal in FCC, correct? In FCC, all the values should be odd, either odd, or all the values should be even. So here, all the values are odd. So this will give signal in the spectrum, in the XRD pattern. Now, take the squares of these numbers, 1 square plus 1 square plus 3 square. How much we get?
11, sir.
11. Yes, we get a signal at 11. Are you able to follow? Right? Take down. For DCC, let me write the next page. Listen, I gave the extinction rules. I'll give once again. Just remember, for simple cubic crystals, all HKL values are allowed. HKL value, all HKL values are allowed. Okay, H can be anything, K can be anything, L can be anything. Okay. Number 2, for body centered cubic, only those planes will give signal for which H plus K plus L, H plus K plus L should be an even number. Only those planes will give signal in the XRD XRD pattern, okay, for which H plus K plus L should be equal to even number. Number 3, for FCC crystal, this HKL values, all the values should be either odd or all the values should be either even. Should be even. All odd, all even are allowed. Okay, 1 1 1 plane, 2 0 0 plane. Only those planes for which all the values, HKL values, all the values should be odd or all the values should be even will give signal in the XRD pattern or XRD spectrum. Number 4, for diamond cubic crystals, right? For diamond cubic crystals, these HKL values should be either all odd, all the values are odd, or all the values are even. Okay, and listen, all the values can be odd or all the values even. If all the values are even, then their sum should be H plus K plus L, okay, must be divisible by 4. Must be divisible by 4. Take down, this is very important. So let me take a problem here. I'll take some cubic crystal. I don't know whether it is simple cubic, BCC or FCC. We don't know. We are going to find out the values. Okay. Now I'll record the XRD spectrum, also called XRD pattern. You are not supposed to say spectrum, it is XRD pattern. Right? We plot intensity in y-axis and 2 theta values in x-axis. Okay, in XRD we plot intensity versus 2 theta. Right? Now we'll get signals, right? Assume that we'll get a signal here, we'll get another signal here, we'll get another signal here, another signal here. So some different angles. Okay. Let this angle, right? The first signal appear at say 20.2 degree. Second signal appear at 28.72 degree. Okay. Now let me write the 2 theta values of these peaks. Okay. This is peak number 1. This is peak number 2, peak number 3, peak number 4, 5. Like that, I'm getting many peaks. This we get it from the XRD spectrum or XRD pattern. Experimentally, we get it. Okay. Now observe carefully how to get the crystal structure, whether it is simple cubic, BCC or FCC, how to identify. It's very simple. What we have to do, listen, first you find out the peaks. Okay, then what is the 2 theta value? Just write it. From this, you find out theta and take the sine square theta, use calculator and find out. Okay, so these are the steps. First, let me do few steps here. First, peak number 1. For peak number 1, we get peak number 1 at 20.2 degree, 2 theta values. Then peak number 2 will appear at 28.72. No need to write, just listen carefully. Just observe what I'm doing. Then third peak appears at 35.36. Fourth peak appears at 41.07. All these values we obtain from the XRD pattern, okay, or the XRD spectrum. Then fifth one, we get a signal or peak at 46.19 degree. Then sixth one, we get a peak at 50.9 degree. Like that we get many signals. Here I have given only 6. Now what to do? These are all 2 theta values. Divide this value by 10. I'm sorry, 2. You'll get theta, correct? These are all 2 thetas. Find theta first. If 2 theta is 20.2, what is theta? 10.1, correct? Am I right?
Yes, sir.
2 theta is 20.2. Then what is theta? Divided by 2, right? So 20.2 by 2 will give me 10.1. Now for 10.1, what is the sine theta you find out? Then take the square. If you take the square, you will get these values. I'll write the values. I'm not going to show you the complete calculation. Okay, all these values I have calculated already, and I'm going to give you the answers. Okay, so if you take sine square theta for this, you will get a value of 0.0308, and for this we'll get a value at 0.0615. Then for this we'll get 0.0922, then 0.1230, then 0.1539, then we get 0.1847. Okay, what I did, these values I got from XRD pattern. For these theta values, I calculated sine square theta, and we know very well sine square theta, right? It is proportional to h square plus k square plus l square. Sine square theta is proportional to this. But before that, these numbers are in fraction. So first we have to normalize. How to normalize? Just divide the sine square theta value by the lowest number. Among the 6, the lowest value is 0.308. So divide this by 0.0308. If I divide, this become 1. This become roughly 2. This become 3. You will get some fractions, but you round off that. Round off. Then this will give me 4. This will give me 5. This will give me 6. Okay, let me write 7 also, which is interesting line. So let me write that. 55.8. For this we'll get 0.2152, and we get 7. Then for 8 we'll get 59.42. For this we'll get 0.2456 as sine square theta. If I divide this by 0.0308, we'll get 8. Okay, now observe carefully. Observe these numbers. Listen, these numbers are proportional to h square plus k square plus l square. Okay, but we know very well h square plus k square plus 7, h square plus k square plus l square cannot be 7, correct? Am I right? Are you able to follow? I have told you already, for cubic crystals, h square plus k square plus l square cannot be equal to 7, cannot be equal to 15. I told you, right? I'm going to 7, h square plus k square plus l square cannot be equal to 7. Therefore, to remove this, what I'm going to do, I'm going to multiply everything by 2. I'm going to multiply everything by 2. Right? So what we get? Here I'll get 2, 4, 6, 8, 10, 12. This become 14, 16, etc. Okay. Now, can anyone tell me which type of crystal, cubic crystal, will give h square plus k square l square? Okay, in these numbers. So all these numbers are even numbers. Okay, so this corresponds to body-centered cubic crystal. It is very easy to find out. Okay, but you should remember the systematic absence. 7, 15 must be absent for all the crystals, all cubic crystals. Okay, then for BCC, FCC, what is the extinction rules? Okay, that you should remember. Then you can very easily answer this type of questions. Okay, take down. which among the following, right? Which among the following will give signal in the X-ray diffraction pattern for a FCC crystal? I'll take some FCC crystal. Which among the following plane will give signal? Okay, let me write here. A 100, B 201, C 220, D 121. Yes, identify among these planes which one will give signal in the XRD for FCC crystal. Tell me. A is not possible because 1 is odd number, but zeros are even numbers. So odd number, even number mixing is there, which is not possible. This plane will never give signal in FCC because you know very well, according to extinction rule, for FCC crystals, HKL values should be all odd. All the values should be odd, or all the values should be even. Okay, so here 1 is odd number, whereas 0 and 0, they are all even numbers. So mixing is there, so not possible. Here 2 is even number, 0 also even number, but 1 is an odd number. So this is also not possible. This is also not possible. What about C? 2 even number, 2 even number, 0 is also even. Yes, all even here. All even. Yes, this will give signal in the XRD experiment. Okay. What about 1 to 1? This is odd. Last one also odd, 1 1, but the central one is even number, so it will never give signal in the XRD for FCC crystal. Okay, take down.
Yes, sir.
Is this among these four, which plane will give signal in the XRD spectrum for a diamond cubic? Okay, so what's the answer? Why option D? The reason is, listen, in option A, what is the rule actually? Extinction rule for diamond cubic is that either HKL value all should be even, all should be odd, or all should be even like FCC, all even. But here, if all the values are even, one more condition we have to see. Okay, let me write here. And H plus K plus L should be divisible by 4. Divisible by 4. Divisible by 4. Number 4. So here one is odd, remaining two numbers are even. According to the rule, all should be odd or all should be even. First condition, okay. But here we have odd number as well as even, so it is not possible. Next one, this is even, this is odd again. See, we are having mixing, so it's not possible. Odd, even mixing is there. Then C, odd, 1 is odd, but 2 is even, mixing, odd, even mixing is there, so it's not possible. Then in option D, yes, all are even. See, 2, 2, 0, all are even. And if you take the sum, H plus K plus L, you will get 2 plus 2, you will get 4. Yes, 4 is divisible by 4. 4 by 4 is 1. Okay, therefore this plane, 2 to 0 plane, will give signal in the XRD spectrum. Okay, take down. The question is this: which among the following plane will give signal in the XRD spectrum or in the XRD pattern for a BCC crystal? Yes, which among the following plane will give signal? Tell me. See, you know very well, for BCC, what is the condition? What is the extinction rule says that for BCC, H plus K plus L value should be even number. Only those planes will give signal. Okay, but if I add here 1 plus 0 plus 0, I am getting the answer as 1. It is an odd number. So this plane will never give signal. Here 1, 1, 1, 1 plus 1 plus 1, I am getting 3. Again, it's an odd number, so this plane never gives signal. Then option C, 2 plus 1 plus 1. If you add, I'll get 4. 4 is an even number. Yes, this will give signal in BCC. in the XRD spectrum. What about the last one? 3 plus 0 plus 0. I am getting the answer as 3, which is an odd number, so you will never get signal for this. Okay, so the only plane among the 4, this is the only plane which will give signal in the XRD pattern for BCC crystal. Okay, take down. Which is not possible? Which among the following is not possible? Okay, for a simple cubic crystal for which h square plus k square plus l square equal to, listen, h square plus k square plus l square equal to some number that is not possible for a cubic crystal. I'll write here, right? Option B 8, option B 9, option D 15. Which among the following number, okay, is not equal to h square plus k square plus l square for a cubic crystal? Yes. So try to remember this. Okay. Yes, you know very well h square plus k square plus l square, okay, cannot be equal to 7 and cannot be equal to 15. Okay, remember those values. Listen, in the XRD spectrum, see, if you take XRD spectrum, here I have given a rough sketch for XRD spectrum. We get so many peaks here. The intensities of these peaks are not equal. Okay, intensities of peaks are not equal, right? Now what I'm going to do, how intensity is related to the structure factor of the crystal. Okay, right? Actually, structure factor of the crystal, right, is an important quantity that decides the intensity of the peaks, right? Yes, so we'll discuss that today. So first of all, what is meant by structure factor? Take down. Structure factor. How to find out this? Okay, we give capital F symbol for structure factor. Structure factor for a particular plane HKL. How to find structure factor for a particular plane HKL? Okay, how to do that? So this is the formula. Try to remember. Structure factor for a particular plane HKL plane is equal to summation J. J goes from 1 to many numbers. It depends on the position values. We'll discuss that. I'll discuss one by one. Okay. Sum of J, Fj. First I'll write the formula. Just write down into exponential. I'll just write exp. It is exponential power 2 pi I into h into xj by a plus k into yj by b plus l into zj by c. Okay, this is the formula for structure factor. Take down. Next point. Here F is capital F denotes structure factor for the plane HKL. What is the small f? Small f j, this is nothing but scattering factor of the jth atom. Take down. Scattering factor of the jth atom. Take down. Scattering factor of the jth atom. Take down. Listen, this is very, very important. Intensity of signals in the X-ray diffraction pattern. Intensity of signals, right, of intensity of signals of XRD, right, X-ray diffraction pattern, PATTERN pattern, right, intensity for particular HKL plane. You know, each family of HKL plane will give a signal, correct? So intensity of a particular HKL plane which gives signal in the spectrum, that intensity is proportional to square modulus of the structure factor F HKL. Take down. square modulus of the structure factor F. Take down. So now let me take a simple example. Okay, so I'll take an example here and I'll show you how to find the structure factor. Example, let me take a primitive cubic, simple cubic, primitive cubic crystal. Okay, so in the primitive cubic, I'll take one cube, one cubic unit cell. Primitive means only corners are occupied, only corners. So in simple cubic or primitive cubic, if only corners are occupied by atoms, then it is called primitive cubic. You know very well. Now I'll take this axis as x, this axis as y, and this axis as z, and this is my origin now. Listen, if only corners are occupied, you can take any atom as origin. Need not that only this. See, I have now in this case I have taken this corner as origin, where x value, y value, z value are all 0. But listen, you can keep origin at any point on the corner. Okay, so all the points, since they are all occupying the same position, okay, for all these corners the values are 0, 0, 0 only. Remember, because you can take any one corner as origin. Okay, there is no there is no any conditions here. Okay, all the corners are equally, they are all equally valid corners, so you can keep the origin at any point on the corners. Right, now listen carefully. In this case, since all these points, right, take the same coordinate 0, 0, 0, so what is the structure factor? Let me write here, F of HKL. Okay, let me write the general formula first. F of HKL equal to, we should take sum J Fj. Let me write the formula, let me write this expression first, then I'll show you. Into exponential, observe carefully, 2 pi I, everything is good. Now xj value, yj value, zj value, all are 0 in this case. Okay, I'll take some jth atom. Suppose this atom is jth atom, this corner atom is jth atom. Now I have taken this as the origin. Remember, you can take any corner as origin, all are equal. Okay, so I'll take this corner as jth atom. For this atom, the coordinates are 0, 0, 0. So xj is 0, yj 0, and zj also 0. So if I put 0 here, this becomes 0, this becomes 0, this becomes 0. So 0 plus 0 plus 0 is also 0. If I multiply this by 2 pi I, I'll get 0. E power 0 is 1. So listen, all these values become 0. So sum of 0, 0 is 0, 2 pi I into 0 is 0, e power 0 is 1. So we get the answer as summation Fj. Summation Fj. Note down. It implies that structure factor F HKL, right, has same value, SAME, same value for all HKL, for all H, K and L. Take down. For all HKL, structure factor is same in the case of primitive cubic crystals. Okay, take down. Now we'll find out structure factor for body centered cubic crystal. Okay, structure factor for BCC, body centered cubic crystals. Now I'll take one unit cell here. So let me draw a cube, and you know very well in BCC all the corners are occupied by atoms. All the corners are occupied by atoms, and we have an atom at the center of the unit cell. Okay, now first we'll fix the Cartesian coordinate points. Okay, what is the, suppose I'll fix this corner as origin. So this is my x-axis, y-axis, and this is, I'll take it as z-axis. And this point, I'm going to take it as origin 0, 0, 0. Remember, all corners are equal here. You can take any one corner as origin. Note down, very important. Now, what about the Cartesian coordinate point for the central atom? Central atom, listen, it is off distance in x-axis. So x-axis off, and it is off distance in y-axis. So 1 by 2, and it is off distance in z-axis. So it is also off 1 by 2. Okay, take note. So here in BCC, we have two different points. One at the corner. Listen, all corner atoms are equal. They are all same. So for all these corner atom, the point is 0, 0, 0 only. Now we have one central atom. For central atom, x value is half, y value half, z value also half. So this point is nothing but 1 by 2, 1 by 2, 1 by 2. Okay, which is different from the corner atoms. Now I'm going to write the structure factor, okay, for this unit cell or for this crystal system. So structure factor for HKL plane, I'll write the general formula first. HKL plane equal to, we have summation here, but now I have two different atoms. So I'll take the sum of two different atoms here. Number one, first I'll take the corner atom. For corner atom, let us assume all the atoms are same. Listen, suppose if you take say sodium metal. In sodium metal form BCC unit cell. So all the corner atoms are sodium. Even the body center atom also say sodium. So let us assume that all the atoms are similar atoms here. If all are similar, then scattering factor for the corner atom and scattering factor for the central atom, say they are supposed to be same, correct? I'm assuming here that corner atoms and body center atoms all are same atoms. They are all same. Since they are all same, the scattering factor for the corner atom, scattering factor for the central body center atom is they are same. Okay. Now I'm going to add for body center and the body center atom and the corner atom. So scattering factor for corner atom into e power exponential power 2 pi I. I'm just using that formula. Listen, you know this formula. Okay, scattering factor F for the corner atom into e exponential means e power 2 pi I. I wrote 2 pi I. Then for corner atom, xj, yj, zj all are 0. Correct. So if I put xj as 0, this becomes 0. If I put yj as 0, this becomes 0. If I put z as 0, zj as 0, this also becomes 0. So 0 plus 0 plus 0, you will get 0. 0 into 2 pi I is 0. So e power 0 is 1. So what we get is, listen, let me write once, then I'll simplify this in the next step. First I'll write 0, 0, 0. Plus, for central atom, the scattering factor is same, into e power 2 pi I into, for central atom, listen, xj value is half, yj is half, zj also half, a, b, c values, since it is cubic, okay, all the edge length are equal. So this is a, this is also a, this is also a. Okay, so what I'm going to do, I'll write this as h by 2a, observe carefully, h by, in the place of xj, I'll put 1 by 2, 1 by 2, so it becomes 2a, right? h by 2a plus k by 2a plus l by 2a. Because a, b, c are all equal in the case of cubic crystal, a equal to b equal to c. Okay, because the crystal is cubic. Right. Then in the next step, see here, 0 plus 0 plus 0 is 0, 0 into 2 pi I is 0, e power 0 is 1, so I'll get simply f plus here f into, now here I have 1 by 2, here I have 1 by 2, here I have 1 by 2, I'll take 1 by 2 as common, so here I have 2, so 2 and 1 by 2 cancel, so what we get is e into I into pi, okay, into h by a plus, or okay, I'll write once, h by a plus k by a plus l by a. Now the bases are same, so I can take LCM. You take f as common here, f into 1 plus e power I into pi, okay, h plus k plus l, h plus k plus l divided by a here, okay, take down. The middle point, I just write the middle point as half. Actually, it is half a, half a, half a. So if I put half a in the place of xj, in the place of yj, and in the place of zj, if you put half a, then this a get cancelled. So you won't be having a here. You won't be having a. So just h plus k plus l. That's all. You won't be having a here. Okay. Remember why? Because we should put xj as 1 by 2a. And we should put yj as 1 by 2a. We just substitute as 1 by 2, right? But actually we should put 1 by 2a, 1 by 2a. So this a and that a get cancelled. I'm sorry, it's not 1 by 2a, a by 2. Yj is a by 2. Similarly, zj is also a by 2. Right? In the place of xj and yj is zj, if I put a by 2, okay, a cancelled. Here also a get cancelled. Here also a get cancelled. So a won't be there. It's a very simple one. Then observe carefully. I'll keep this f as such 1. Now listen. How to write this one? I can write this as e power I pi whole power h plus k plus l. We can write like this. What's the value of e power I pi? You know very well Euler's theorem. You might have heard about this. According to which e power I pi can be written as cos pi plus I into sin pi. Sin, all pi values are 0, so this becomes 0. This quantity becomes 0. Cos pi is minus 1. So e power I pi value, e power I into pi value is minus 1. So I'll place minus 1 here. Let me write in the next page. Just copy down. Let me continue. The structure factor for HKL plane is equal to f into 1 plus e power I pi is minus 1. So minus 1 power h plus k plus l. Okay, minus 1 power h plus k plus l. Observe this carefully. We are working for BCC crystal, correct? Body center cubic. Now, listen, what will happen if h plus k plus l, if it is odd number? Listen, I have two conditions here. If h plus k plus l is odd number, what will happen? Can anyone tell me? If h plus k plus l is odd number, then minus 1 power odd number is minus 1. Minus 1, and here we have plus 1. So minus 1 plus 1 becomes 0. So structure factor becomes 0. If structure factor is 0, intensity becomes 0. So for BCC, if h plus k plus l is odd, those planes never give signal, because for those planes, structure factor is 0. What will happen if h plus k plus l is an even number? If it is even, minus 1 power even number, it becomes plus 1. Plus 1, this is plus 1, so you get 2. So structure factor becomes equal to 2f. So these planes, right, they are not, the structure factor is not 0, which means these planes will give signal in the spectrum. Is this clear to all?